I'm going to explain why these answers are these answers and why that answers are not these answers based on my own understanding of Kubernetes for some time. So we're going to work with the journey together. So the first question says, in a cloud native world, what does the IAC abbreviation stand for? IAC abbreviation actually stands for infrastructure as a code. Example of infrastructure as a code is Terraform. It is plumbing, it is Ansible, it is Helm, because they make use of code for the provisioning or configuration of our infrastructure. So the answer is infrastructure as a code. Another one here is, what is the primary mechanism to identify group objects in Kubernetes? I also have my Kubernetes documentation around me. So if we need to check something according to the documentation, we will both check together. So what is the primary mechanism to identify group objects in Kubernetes cluster? The primary mechanism to identify group objects is labels, not label selector. You have to label a particular group of pod or a node before you select them in a pod. So label selector is not the answer. Custom resources is not the answer, but label is actually the right answer. Another one is, let's assume that an organization needs to process large amount of data in bursts on a cloud-based Kubernetes cluster. For instance, each Monday morning, they need to run a batch of 1,000 complete jobs of 1 hour each. And this job must be completed by Monday night. What is going to be the most cost-effective method? The most cost-effective method is by using, the answer is B, which is leveraging the Kubernetes cluster autoscaler to automatically start and stop node as they are needed. What does this mean? This means that we are making use of the concept of cluster autoscaler. What is a cluster autoscaler? A cluster autoscaler is a situation or a mechanism in which the nodes are being added or removed based on the application demand. If the application demand is higher, more nodes will be automatically be added. And if the application demand is low, the node will be removed also. So the answer is B is the correct answer. What is a Kubernetes service with no cluster IP address code? A Kubernetes services with no IP address code is called a headless services. It is called a headless services. It is called an headless services. So since it's called an headless services, these options here, so the right answer is A. If you want to check, we go to the Kubernetes documentation and click headless. Let's check. Let's check headless in 12. In terms of services, when we say a service is headless service. Let's check again. Headless service. These are headless service. This is no. We'll check this now. Headless services, service cluster IP, statically, dynamically, and this is, so we want to find where they use an headless services. I wish I could. And headless services is majorly used for a stateful set. because we don't need to expose a stateful set. So this is an headless service. Sometimes you don't need load balancer and single service IP. In this case, you can create what are termed headless service by explicitly specifying none for the cluster IP address, which is spec cluster IP. So we got this as our spec cluster IP. So that is the answer for that. What is the main role of the Kubernetes DNS within a cluster? The main role of a Kubernetes of a DNS in a Kubernetes cluster is actually to provide consistent names for pod and services for workload that need to communicate with each other. And this is the answer. And what is a good way to remember it? Anything related to DNS, which is called domain services, your DNS is connected to the domain issues and configurations. So that will make use of your kubelet. So when we're talking about DNS, we are trying to give it a domain, a consistent name for our pod and our services for workload so they can communicate. Because normally a pod has an IP addresses, but they need a communication which is called a domain name service. Going to the next question. Which of the following characteristics is associated with container orchestration? A good characteristic that is associated with container orchestration is called dynamic scheduling. Why is this dynamic scheduling? When it comes to an example of a container orchestration is Kubernetes, this is Docker Swarm, it is Mesos. So all of these tools I just mentioned, they help us in scheduling of our containers, and so dynamic scheduling is actually the right answer for that. The next one, which command will list the resource type that exists within a cluster? The command type that will list the exact resource type that is present is called kubectl API resources. When you click kubectl API resources, it's going to bring all the API resources that are available in that command. The next one is, which API project is recommended way to run a scalable stateless application on your cluster? If you read this now, you will see this, the keyword here is scalable stateless application. When we talk about stateless, we are talking about deployments. When we are talking about stateful, we are talking about databases. So stateless is talking about your front end, your back end. But when we talk about StatefulSet, we are talking about the database. So the right answer for this is deployment. Another question here is, what best describe a cloud native service discovery? The right answer here is option A. And why is it option A? It is a mechanism for application and microservices to locate each other on a network. If you look at what we actually discussed a few minutes ago, where we talk about service discovery, we talked about consistent DNS name. And why do we have a consistent DNS name? Is to enable our microservices to talk to one another. Next is, which is an industry standard container runtime with an emphasis on simplicity, robustness, and portability. For simplicity, robustness, and portability, Containerd is actually the right answer. Now, which group of container runtime provide additional sandbox isolation and elevated security? When we are talking about sandbox isolation and elevated security, we talked about run C and Kata, which is option C is actually the correct answer for that. Next one is, which statement about the Kubernetes network model is correct? About the Kubernetes model, the right answer is pod can communicate with all pod without NAT. What is NAT? NAT is actually called network address translation. You actually don't need a NAT for those pods to communicate between a node and another node. So the right answer is actually B. Moving on to the next question. What Kubernetes component handles network communication inside and outside a cluster using operating system packet filtering if available? They said a Kubernetes component that handles network communication inside and outside of the clusters. Now, if you look at those options very well, you will notice and you agree with me that a queue controller manager is actually in charge of watching the loop of a current of the desired state and the current state. So that has nothing to do with network communication inside and outside the pod. A good example is if you look at etcd, etcd is definitely not the answer because etcd is actually associated with a data store or a database. Why? If you look at kubelet, a kubelet is an agent that ensures the communication that goes in our worker node are working efficiently and properly and makes a report back to the API server. So kubelet is not the answer. The right answer and the only answer here is a kube proxy because everything networking communication is directly handled in a kube proxy. Next is, which of the following workload require a headless service while deploying into the namespace? We already explained this time without number. For headless services, we need to think about why do we use headless services. Some of you would like to know. We use an headless services because we don't want traffic to be directed to a database. A database is a private instance where you don't want a traffic to enter. So that is when you use an headless service. And when we have a database, the rightful answer is a stateful set. A stateful set doesn't need a service name. What are the types of services? For those that are just joining, that are looking at, okay, yes, I want to use this, I want to know as much as possible. What are the types of services? We have 4 types of services. The first type of services is called the node IP, which is used to allow communication, into our cluster. Then we have a cluster IP. When do we use a cluster IP? We use a cluster IP where we want to make a communication within the cluster itself. But when we need to make a communication on our system or this thing, we use a node port IP. But if we want to make a communication from the outside world, we use what they call a cloud load balancer or an external name for our communication. So the right answer here for this number 14 question is actually a stateful set, because in a stateful set, we need privacy and we don't want our services to be accessed externally. So we want a private connection, and a stateful set is the right workload deployment. 15, how are replicas set and deployments related? Yes, the replica set and deployments are so similar to each other, but the differences between a replica set and a deployment is that a deployment has an advanced feature where you can actually roll out, roll back, and do some other advanced feature. But unlike replica sets, which is mostly consigned, a deployment will actually do what a replica set does and does more. But a replica set on its own is just more concerned about the number of counts of the pod. If the number of counts of the pod are exactly the same way, let's assume you deploy 6 pod and 1 pod get damaged. The replica set controller is in charge of making sure that the 6 number is constant on your cluster. Thank you. So your right answer here is deployment manage. The right answer is deployment manage replica set and provide declarative updates to the pod. The next one is, what is the purpose of the CRI? When some of you might want to know what is the CRI. A CRI is called Container Runtime Interface. So the purpose of a container runtime interface is to provide an interface allowing Kubernetes to support pluggable containers. So the right answer here is option C. Next, services and pod in Kubernetes are what? They are YAML objects. You can write in YAML, you can write them in JSON, but YAML is the right answer for this question. How does dynamic storage provisioning works? Dynamic storage provisioning actually works in when a user requests dynamically provision storage by including and excluding storage in their persistence volume key. So you pick option A for your answer. Which of the following capabilities are you allowed to add to a container using the restricted policy? Using the restricted policy, the right answer is called netbind services, which is option D. What is a probe within Kubernetes? A probe within Kubernetes is actually a diagnostic performed periodically by the kubelet on a container. We have two types of probes. We have liveliness probe and we have readiness probe. What is liveliness probe? Liveliness probe is used to make sure that our pods restart whenever they are bad or damaged. And what is readiness probe? Readiness probe is to make sure that our pod is ready to receive traffic before it comes. So we use them to troubleshoot and help us to make sure that to monitor that our pod is actually ready for traffic. If it's not ready, the readiness probe we know through the readiness probe that this pod is not ready to receive traffic or this pod is actually ready to receive traffic. The next one is, what is the resource type used to package set of containers for scheduling in a cluster? The right answer here is a pod. A pod is the right answer. What type of service require manual creation of endpoints? Manual creation of endpoint is you have to use services without selectors. Those are the right answer for that. And the right is not a load balancer. I told you what a load balancer is. A load balancer is using the cloud to make sure that traffic enter into our clusters. So the right answer here is service without cluster. What does vertical scaling and application deployment describe best? What's vertical scaling is? A vertical scaling is talking about you are increasing the capacity of the resources. You are not increasing the numbers of the resources. You are actually increasing the capacity. So if you are increasing the capacity, that means you are trying to add, you are not adding more node, but you are actually more, the right answer for this is actually you are adding more resources to the application demand. That means if the application is increasing, maybe you are previously on a 500 MB memory, but because the application demand is increasing, it will increase automatically into 1000 because we integrated what they call vertical scaling. So the right answer here is actually C. Then now, in the Kubernetes platform, which component is responsible for running containers? The components responsible for running container is actually it's not your etcd. Why is it not etcd? It is not etcd because it's related to the database. The cloud controller manager is not the answer because we're not talking about load balancer or storage or this thing. The CIO and the kube controller manager are actually the two answers, but the answer is not a kube controller manager. Why? Because a kube controller manager is in charge of replication controller, node controller, and store. So the right answer here is actually CIO. Then this is the last one for this series. What factors influence the Kubernetes scheduler when it places pod or node? What are the factors that the Kubernetes scheduler actually consider before placing a pod on a node? They have a lot of requirements, but based on this question, we are looking at the pod memory request, node taint, and pod affinity. Some of you might be asking me, what is a pod memory request? A pod memory request is that the pod itself is asking, I need 500 MB for me to be able to work very well. And what a node taint is actually when the node has actually been labeled or tainted for a particular pod and only attract those kind of pods to itself. And now we have a pod affinity. A pod affinity is maybe we are trying to put a particular group of pod in one node, or we're trying to put a particular pod in one particular zone. So the right answer here is actually A. And that's the end for the series. And thank you for being here with me. And I wish you luck in your exam, and the next series will go on.